In this first problem, we have 2 diamond rings and 4 silver rings that cost $1,440. So we can kind of represent it this way. 2 diamond rings, 4 silver rings equals $1,440. In addition to that, we know that a diamond ring and a silver ring cost $660. So if we were to group together a pair of diamond and silver rings, like so, we know that that pair of rings is worth $660. Then we have another pair of diamond and silver rings, and that pair of rings is also worth $660. So what we have now is $1,320 plus 2 silver rings is equal to $1,440. And of course you could subtract that $1,320 from the $1,440, and what you'd be left with is $120. And that tells you that 2 silver rings are worth $120. And since they have the same value, split it in half, and we have 1 silver ring is worth $60. And that was the question that was asked. How much does a silver ring cost? Now that's really the simplest way to go about a problem like this. We could have done it all algebraically, which is not too far removed from what we just did. And we would start with 2d plus 4s is equal to $1,440, where d and s refer to the value of the diamond ring and the value of the silver ring, respectively. So setting this up algebraically, we end up with a system of equations, and there are a number of different methods that we could use to solve this. And I'll see if I can do them both ways so that you can get some familiarity with that. The first method would be called the substitution method, and in that case we will use the second equation. Since we have the d and the s already by themselves alone, we can solve for one of them. Since the end result is to find out how much the silver ring costs, we can simply solve for d here. And the reason we do that is because we can now substitute for d in the first equation and give another name for d, which is 660 minus s. And at that point we have only one variable, and when we have one variable, one equation with one variable, we can solve for that variable easily, or more easily. So as we set up the first equation, instead of writing d, we're going to write 2 times 660 minus s, and it's very important to put that expression in parentheses because we don't want to have it 2 times 660 and then minus s. We need to have 2 times the whole quantity 660 minus s. Then plus 4s, and that all equals 1,440. Now we're going to use the distributive process to multiply 2 times 660 and 2 times s. And at this point we have 1,320 minus 2s plus 4s. So what we want to do is combine the like terms, negative 2s plus 4s. And that gives us 1,320 minus 2s is equal to 1,440. And basically that's where we were in the previous equation. Sorry, that should be 1,320 plus 2s. And that's where we were with the previous method that we did this. And you can see what happens. You're going to subtract 1,320 from both sides, divide both sides by 2, and you end up with s equals 60. So this is what's called the substitution method. Now I'm going to try this one other way. And we call this the elimination method. And what we're going to do is that we need to have one of the variables go away. And the way I can do this is multiply the whole second equation, d plus s equals 660, by negative 2. And now I simply add each of the 3 columns that I have there. And when I do that, the d's will zero out, and I'll be left with 2s equals 120, which brings me to this step in the original process. And you can see once again that we'll get the same answer. So we have 3 different ways. One is using this drawing a diagram method, and then the second way using the algebraic methods of substitution and elimination to solve the system of equations that way.